Major earthquake. During the evening of February 8 of 2025, a major earthquake struck the Caribbean Sea between the coastlines of the United Kingdom's Cayman Islands and Honduras. This occurred at 5:23 p.m. local time, causing the ground to rapidly shake back and forth for 36 seconds, which, although no one lived in the middle of the sea where this earthquake struck, if they had, the most intense shaking would have looked something like this, equivalent to about 70% the acceleration due to gravity. As the seismic wave expanded outwards, it would eventually be felt by up to 32 million across 12 countries, representing the planet's largest earthquake in 21 months. Due to the size and duration of this earthquake, along with the fact that it generated a tsunami, you might have figured that it was quite destructive. However, there were no deaths, no injuries. The tsunami wave only reached a maximum height of 1.6 inches or 4 centimeters, and there are only highly scattered reports of power outages in Belize and Honduras, along with very few reports of cracks that formed in a few structures. In other words, the damage is unlikely to total even $1 million US. So, why exactly was such a major earthquake not deadly? After all, a section of the fault which ruptured moved by up to a whopping 12 meters or 39.4 feet in a mere 36 seconds. The answer for this is twofold. Geologic setting first, let us look at why this earthquake occurred. If you look at the area between the nations of Jamaica and Cuba, you will see a vast deeper feature known as the Cayman Trough. This trough, which is more than 4 kilometers or 2.5 miles deeper than the surrounding seafloor in some areas, represents the boundaries of two tectonic plates. These plates are the North American plate to the north and the Caribbean plate to the south. The aforementioned trough is not expanding both to the north and south like you might think, but instead contains a spreading center which is pushing it apart to the east and west. This movement and related strain causes the boundary between the two tectonic plates to slide past each other on what is known as a strike-slip fault, sometimes causing strain to build up to such an extent that a major earthquake is eventually triggered. In the case of this latest earthquake, that involved in areas moving by a few millimeters, minimal damage to up to 12 meters that measured 125 kilometers or 77.7 miles long and 15 kilometers or 9.3 miles wide. Because strike-slip faults do not involve a significant vertical motion to them, they only rarely generate large-scale destructive tsunamis through displacement of water in very specific circumstances, one example of which is through the generation of submarine landslides. In this case, no significant underwater landslides appear to have occurred, although some minor motion is likely responsible for the small observed 4-centimeter tsunami. As to why damage on land was so light. Location. While the major strike-slip earthquake had a fairly shallow epicenter of 10 kilometers or 6.2 miles, the strongest ground shaking it caused was only equivalent to an MMI 4.5, which looks like this, and as you can see by the description for that level of shaking, it makes perfect sense why only negligible if any damage occurred. Aftershocks. So, what happens next? Probably a few aftershocks of a smaller magnitude. While we cannot predict how many aftershocks, or earthquakes induced by the main shock, will now occur, generally speaking they follow a nice declining 1/x pattern over time, meaning they decrease in abundance as the hours, days, and subsequent weeks progress. However, the largest aftershock tends to be about 1.2 magnitude smaller than the main shock, meaning that the most likely largest aftershock will have a magnitude of approximately 6.4. With this in mind, strike-slip earthquakes tend to produce fewer aftershocks than earthquakes associated with other faultline types, so the odds of a magnitude 6.4 or larger aftershock happening is probably under 50% rather than being strictly about 50%. A few keen-eyed viewers might have noted an apparent and suspicious long-term trend along this plate boundary where each magnitude 6.5 plus earthquake occurred further to the east along the fault than the prior such event. While this might look like a true pattern, it isn't actually one. It is pure coincidence, as you can see when I overlay all magnitude 6+ earthquakes which have struck since 1976. As a final note, I would like to thank my new YouTube channel member Pam D for supporting my